So welcome everybody to Kubernetes Identity Management. We're going to be teaching you how to secure your clusters with identity. So we got a 2-hour session. We will be taking a break. This is going to be an interactive session and is going to have a few labs. So we're going to be covering authentication, authorization, pod security policies, how to debug it, things like that. So just to get started with a little bit of housekeeping, and I think I can actually put this in the chat window to make everybody's lives easier. Figure out how to do that real quick. More chat. Here we go. So I'm going to send this to everybody. This bit.ly link will bring you. Sorry, here we go. Here to a gist on GitHub. The first thing you're going to want to do is go to this Google spreadsheet that's linked to and pick a cluster. Any cluster. Once you have chosen a cluster, go ahead and just put a little X to make sure that it's taken. We got plenty of VMs. We got a little less than 20 people in here. We got 125 VMs. So please feel free to spread out, pick one at random. These VMs all have the exact same key. So let's make sure that, yeah, we play nicely, everybody. Nobody's trying to take over anybody else's VM. Once you pick a VM, can I come back here? The keys to access it are in here. So whether you're using OpenSSH or you are using PuTTY, you can use either of these keys. Don't start with the lab quite yet. Once you get yourself settled in, you're able to SSH in to your chosen lab. Go ahead and just kind of hang out and let's get started with the presentation portion. So what we're going to do is, because this is a very deep topic, what I'm going to do is I'm going to be keeping an eye on the Q&A section. As you ask questions, I'll go ahead and at each slide, after we get past the slide, I'll go ahead and check the Q&A section to make sure that there are no new questions. With that, let's go ahead and get started. So let's talk about what we're going to cover. We are going to cover a little bit, we're going to talk a little bit about host level authentication, kind of that soft underbelly of the Kubernetes clusters. We're going to spend a lot of time on authentication. This is one that, you know, it's a username password, right? What's the big deal? Well, Kubernetes is really unique in a lot of ways, especially in the enterprise world. So we're going to talk a lot about specifically the OpenID Connect protocol, why it's most likely the one you should be using. We're going to talk about several anti-patterns, for instance, certificate authentication, why you shouldn't be using it. And we'll get into impersonation as well. That's kind of a really interesting use case and one I've really enjoyed using as of late. We'll also get into authorization. So we're going to spend a lot of time on authentication, but once you get through the authentication part, you then have to figure out who has access to what inside the cluster. So we're going to talk about RBAC. How do you debug it? How do you design your policies? We're going to touch a little bit on network policies, just from a design standpoint, but really the focus is going to be on RBAC and then on pod security policies, how to handle them, what's going to happen to them, etc. What we're not going to talk about, this is not an introduction to Kubernetes. There is an assumption that you have some basic understanding of how Kubernetes works. Yeah, we won't be covering things like what's a pod, what's a deployment, things of that nature. We're not going to really get into how you do certificate management. We'll talk about it from a high level as to how it applies to Kubernetes, but we're not going to go through how you actually stand up a CA, get a certificate issued, things of that nature. And then the last few here, kind of basic security of your environment. There's often a lot of talk about how Kubernetes is not secure by default. That is 100% accurate. There are so many things that go into doing that I would not possibly do it justice in a couple of hours. Our focus is really going to be on the identity side. Who's accessing your cluster? There we go. So let's talk a little bit about host level authentication. Your host is the soft underbelly of your cluster. If somebody has access to your host, think about this. You're running Docker, most likely. There's some cluster. There are a lot of distros out there that don't use Docker, but at some level, you're running some kind of container infrastructure on your host, and containers don't really have that great of a security boundary. You have to put in a lot of work to make that security boundary work. And the fact is that I'm on your host. I have root access to your host. I win. I have access to all your volumes. I have access to all the processes. Once you get into your cluster, if you run PS or top, you'll see all of the processes running inside of containers, even though it's running inside of Kubernetes. So once I have your node, I win. Even better if I own your control plane. I have access to your etcd data, all of your keys. It really is the soft underbelly. And so there are a couple of different strategies you can use when it comes to identity and locking down access to those hosts. There are those that will do identity by Ansible, I call it, where you're provisioning certificates for SSH. I might have been guilty of that once or twice, but that doesn't scale. There are several centralized options. So you might be looking at things like free IPA, Active Directory. There are a lot of different options there for managing who has access to your host. Or you could just say, you know what, nobody's going to have access to my host. So if you're doing a managed cluster on AKS, EKS, etc., you might just not give anybody access. Here's the trick though. If one user needs access to your host for whatever reason, then you need to spend the time to make sure that you're managing access properly. Because there are these memes out there and videos out there of different doors where they have these giant locks and then they're defeated because somebody can just reach around and open it from the inside. Not securing your host, not making sure people have access to your host is kind of like that. So we're not getting into details of how to do that because that differs very much between different distributions, different platforms. But as you're starting to design your cluster implementation, do not ignore who has access to the hosts. So let's talk. Did I miss one? I did miss one. I'm sorry. So sorry to jump around here, but let's talk a little bit first about what is identity management. Who, what, why, and specifically when we're talking about Kubernetes. So the who is, who are you? And kind of like the scene from the Matrix where Neo is going to visit the Oracle and is waiting in her kitchen and talking to all the kids there, and the kid's bending the spoon in front of him, and she says, the trick is to realize there is no spoon. That's what you have to realize when it comes to identity in Kubernetes. There are no users. There's no user object. There's no group object. Everything has to be asserted when the API is called. And that's one of the things that's interesting about Kubernetes. We think about Kubernetes as this overall system, but it's an API. So you might be interacting with Kubernetes with kube control. You might be interacting with Kubernetes with a dashboard or a local management system or a centralized management system. You might be using Kiali if you're using Istio. There are all these different platforms that you might be using to interact with Kubernetes that you'll authenticate to. And we're going to talk about how authentication for those should work. But at the end of the day, Kubernetes is just an API. So every single API request has to be self-contained. You can't have an API request that relies on another API request session. It's not like when you go to a web browser and you log in, you've got a cookie that you pass back and forth. That's your session. It doesn't exist. So every single authentication call has to include what you're able to do and who you are. So in the Kubernetes world, that boils down to a couple of different options. The first one we often run into is certificates. We launch a cluster and there's that master config file. It's got a certificate in it. It's got that master key that can do everything. And that's great for break glass in case of emergency, but you don't want to use it day to day, and we'll talk about the reasons why. Then you've got OpenID Connect. This is kind of your workhorse of identity in the Kubernetes world. This is the one you should be using, quite frankly. And that may also include cloud or managed-based clusters. We'll talk about those as well. But at the end, this is a protocol that has thousands of hours of peer review. And it lets you say who you are and what you can do in a very elegant way, and in a way that is much safer than most of the other options. You use impersonation, which is an interesting technique. We'll talk about that. You could do custom authentication. I would implore you, please never, ever, ever do this. Just don't. It's like writing your own encryption. You're begging to have problems. If you're a cloud vendor and you have a token system that you're using to secure all of your APIs, that's a different story. But if you are deploying Kubernetes into your environment, chances are a custom implementation will be much, much less secure than existing options. And then we've got service accounts, and we'll talk about those. Service accounts have a lot of issues around them, especially when it comes to identifying users. They're not meant to represent people, they're meant to represent systems. And people who use them to represent people are often asking for issues, and we'll get into that as well. So we've identified who you are. The next question is, what can you do? In Kubernetes, that's typically done by RBAC. And so you combine your subject, who you are, a role, which is really a list of permissions and what those permissions apply to, and a namespace, where those permissions apply. And that gives you a role binding. Cluster role binding, you take away the namespace, but it's the same idea. You can reference groups inside of your role bindings, but just like users, they don't exist. You have to assert them as part of your authentication process. And then finally, the why. Why should you have access to the system? Kubernetes doesn't give you that. We'll talk a little bit about that, but when especially you're talking about an enterprise deployment, you will often be looking for, hey, why should somebody have access to this namespace or this cluster? Should they still have access? That's an external workflow. That's something that you're going to have to build on your own. So we talked about host level authentication. Okay, now we can talk about OpenID Connect. So like I said before, OpenID Connect, it's got a heavy peer review. It's a standard. It's gone through that review process. It's a very complex standard that we'll get into. And there are a lot of different RFCs. Please don't try and implement this yourself. There are plenty of implementations out there. We're going to be using Open Unison for our labs today. That's my company's open source project, but everything is applicable to Keycloak, DEX, WSO2. You could use ADFS. You can connect directly to Google or Okta. There are so many options. Please do not try and write this on your own. And these next couple of bullets are really great, especially when it comes to locking down your clusters. Short-lived tokens. If anybody has attended the KubeCon virtual in Europe, that was there was a great session by Ian Coldwater and Brad Giesemann about advanced persistent threats inside of Kubernetes and what those look like. And amazing bit of work, amazing bit of engineering. They all start with cluster admin. So if you think about the way that Kubernetes works, like I said, it's an API. You're making API requests. You have to send a token over the wire that Kubernetes knows how to interpret. So if somebody gets a hold of that token, they could abuse it. So one of the best ways to minimize your blast radius, if that token were to be leaked, how would that token be leaked? CNIs, I think it was Calico, had a bug a couple of years ago where they were leaking tokens. Just logging, people sometimes will log it and not realize it as part of their debug logging, or they're doing a dump environment variables. So if you have that token really short-lived, and I'm talking like 1 to 2 minutes is my kind of where I try to be, you have enough time to finish the operation, but by the time somebody gets the token, realizes what it is and tries to use it, it's already expired and becomes useless. And then multi-factor authentication. Again, the easiest way to get somebody's password is to just ask. More polite you are, more often they'll tell you. And so the easiest way, one of the easiest ways to make sure that your system doesn't get abused is multi-factor authentication. It was Google, I think it was like 2 years ago, published a paper on how they were able to cut down phishing attacks by like 98%, some ridiculous amount with software tokens. And it was like 100% with hardware tokens, ridiculous amount. So multi-factor, and because OpenID Connect works through a web browser, you have an unlimited range of multi-factor options that you can work with. And the great thing about this process is it externalizes your authorization. Once we start talking about RBAC, you'll realize pretty quickly that trying to load up a lot of principles directly into your policies gets messy very quickly. Whereas with OpenID Connect, you can just embed group memberships into that token and reference those group memberships. So you're not rewriting or updating these policies on every request. And then finally, Kate's never has your credentials, especially if you're working in a regulated industry where you get the big giant spreadsheet of controls that you have to fill out every time you deploy something. Well, guess what? There's a bunch of controls that you can just ignore because the password never goes through Kate's. Kubernetes never knows what your credentials are. It's just validating that you have been authenticated. That presents a lot of value from an implementation standpoint. So what are the downsides, right? If this is so great, why doesn't everybody want to do it? So first, it is complex. We're going to get into the individual steps, and it can be intimidating. It took me a while to figure it out, and I will not lie. There are times where I find new aspects of the spec. I think one of the first ones that I saw a graphic a couple of months ago where OpenID Connect is composed of like 40 some odd specs, different RFCs and whatnot. So it can be very intimidating, and it's okay to feel intimidated by it. Excuse me. To do it correctly, you need a web browser. There are profiles in OpenID Connect, and there are plugins where you can do just kube control login. It asks for your username and password, and you're able to use a token. Those were put there for scenarios where you don't have a browser. There were actually, or you can't handle redirects properly. So it was originally designed for like you've written a web app that uses OpenID Connect, like a single page application that can't handle a redirect. So it's just going to query the identity provider with the username, password, and get back a token. That doesn't really exist anymore. Web frameworks know how to handle that. And in fact, the next version of OAuth 2, which is the primary spec OpenID Connect is built off of, is deprecating. I'm pretty sure it's actually deprecating that profile. In order to do it correctly, you need to use a web browser. Now, this can introduce some other challenges because, like I said, Kubernetes is an API. So if you're running kube control locally, how do you log into a browser and then transfer that context into kube control? We'll talk about that. There are numerous patterns for handling that scenario. And then finally, bearer tokens are incredibly easy to abuse. So what do I mean by bearer tokens? A bearer token is like a ticket to get into a ball game or a match or whatever your favorite sport is. It's a piece of paper. You use it to get in. If somebody else, tries to use it before you, and then you try to use it, we scan the barcode. This ticket's already been used. Bearer tokens are that easy to abuse, which is why it's so important to have a short-lived time span. There was a spec a couple of years ago, 2 or 3 years ago, maybe. There was an attempt to build in what's called channel binding, where it was this idea that the token was tied directly to the TLS connection that was a part of. Microsoft does this, for instance, in the Kerberos world now. But if you think about it, like in the cloud native world, this really wouldn't work because you could have like 12 different proxies, right? I mean, you have your external, you have your offloader, and then you have an ingress controller, and then you have you might have an MTLS controller if you're going that route. So that kind of channel binding never really works. So it's really, really important. Short-lived tokens. That's a really important aspect to keeping OpenID Connect secure. Nothing in Q&A. So let's look at how OpenID Connect works. So this diagram is taken right off of the Kubernetes Authentication website. And we'll be going through this process. So if the diagram, you have a hard time visualizing it, totally understand. You're going to log into an identity provider. So this is the thing that's going to authenticate you. In our instance, we're going to be using Open Unison, but this DEX, Keycloak, Okta, ADFS, whatever. You're going to authenticate. And you're going to get 3 pieces of information back. You get an access token, an ID token, which identifies who you are, and a refresh token, which is what you can use to get a new set of access tokens and ID tokens. Now, Kubernetes doesn't use the access token. Kind of throw that one away. What it really focuses on is the ID token. This is what's called a JSON web token. Bit of JSON that just says who you are, when the token is good to, not before and not after, what groups you might be a part of, and when, and is digitally signed with the certificate from the identity provider. So now you take that token and you put it into your kubectl configuration. Kubectl get pods. What's going to happen is it's going to take that bearer, kubectl is going to take that token, shove it into a header, the authorization header called bearer. It's going to send it to the API server. At which point the API server is first going to see, is the signature valid and has it expired? So let's make sure that it's a valid, it's a valid token. It's going to do a couple of other checks to make sure that the token is formatted in a way that's expected. So, making sure that the client ID is correct, things of that nature. The issuer is correct as well. And then it's going to do an authorization check. So we'll talk about authorization, but it's going to take the information from that token, hand it off to the authorization engine so it can run through RBAC policies. And it's going to do whatever you asked it to do, return a result, and the result goes back to the user. So this all happens in the blink of an eye. Now what becomes interesting is if that token has expired, then what kubectl will do is say, okay, this token is expired. So I'm going to go back to the identity provider with my refresh token. Now here's where the security of the refresh token comes in. It's a one-time use only token. Once you've used it, it is no longer valid. So that refresh token goes back to the identity provider. Identity provider gives you back a new ID token and a new refresh token. So somebody can get access to your ID token. They can continue to use it until it expires. Somebody gets access to your fresh token, you've already used it, it no longer works. The other important aspect of the refresh token is it only goes between you and the identity provider. It never goes to your Kubernetes infrastructure. So somebody leaks it, can't leak it, right? It's like a password. They can't leak it from your Kubernetes infrastructure because they never get it. So best practices, again, short-lived tokens. Typically, I find that refresh tokens are going to be scoped to your session idle timeout. So if we're talking about, most corporate enterprise policies are anywhere between 15 to 20 minutes. If you've got that short-lived tokens, those refresh tokens are going to be constantly refreshing. Include both users and groups in the claims. Now, when you look at how you identify users, there is a kind of a instinct to go with email address. Please don't. Email addresses are based on names. Names can change. Yes, it can become a little annoying trying to look up what UUID associates to a user, but by leveraging item or not idempotent, a non-changing, something that's not based on anything in particular, truly random. I'm a big fan of type 4 UUIDs. You now have a cluster that if somebody does change their name, and look, there are several situations in our lives where names might change. We might not like our name, right? People get married, they change their last names, and might change their email address. There are all sorts of scenarios in this world where somebody might change their name. You don't want to then have to turn around and change all your authorizations because of that. So, please don't use emails as your identifier. It's an anti-pattern. So as much as everybody loves hearing me talk, why don't we start having some fun and actually get going with the actual lab. So what we're going to do is I'm going to exit presentation mode, and then we will go ahead and get started. I'm going to do the lab with everybody. Usually this lab takes a good 15 to 20 minutes, depending on how comfortable people are with copy and paste in a terminal window. But I'm going to go very, very slowly so people can follow along. And then I will be keeping an eye open on Q&A. All right. And yes, actually, I will shoot out a link. This is actually all open source. I'm answering the question, is it possible to get a copy of the presentation? Absolutely. It's on SlideShare. And then what I'll also be doing is sending out a link at the end to the source material. This is all open source in our GitHub. So if you wanted to rebuild this cluster on your own later, you're welcome to do so. All right, so let's go ahead and pull this up. And so lab one, we're going to go ahead and start our where's Firefox? There we go. I'm going to make this a little bit smaller so that way we can do a side by side. So the first thing we're going to do is we're going to log into Open Unison. Now, my IP address, and I hope everybody's taken an IP. I'm just kind of going through here and scanning it real quick. Anybody who came in a little bit late, if you go to the bit.ly link at the very beginning of this chat, there'll be a link to this spreadsheet. This spreadsheet has a list of all of the VMs that have been provisioned for this workshop. Pick any VM that doesn't have a little something in the taken column, and that'll be your VM. So that'll be your VM for the rest of the morning. So once you've picked your IP, the first thing we're going to do is log into Open Unison. So one of the things, we've all seen the memes. It's not DNS, but it's DNS. So I love for these types of workshops and whatnot, a service called nip.io. It lets you send any IP address to it and it'll come back with a host name. So instead of having to, pre-provision a bunch of hosts and whatnot, this is so much easier. So I'm going to go ahead and do this with my IP. So this one's mine. And again, everybody, good housekeeping. So I'm going to log into here. Nope, That's definitely not right. There we go. .nip.io. So you can see here what I've done is I've replaced this IP address with my IP address. So let's go ahead and log in. Move this. All right, I'm going to make this bigger. So I'm going to log in with our user, Kate's Lab. And $start123. So this is what you should see. I'm actually going to close this out for now. I'll keep an eye on the Q&A. So this is what you should see. This is the Open Unison Access Portal for Kubernetes. Now, this also includes our provisioning tools to be able to create new namespaces. We'll talk about that a little bit later when we get into RBAC. You click on your name, you should see that your role is user, a little bit of info about you. But there's not a lot here. So first thing we need to do is make ourselves an administrator. We've got to bootstrap ourselves. So you could go through and request access to a lot of things, but we are going to do this very simple. So I'm jumping now down to step 5. This is going to require you being logged in to your server. So I'm going to go ahead and just copy and paste this. All this is doing is, instead of us going through the process of going through an access request and approval, we're just bootstrapping and saying, you know what, I'm going to make myself an administrator. So once you've run those 2 commands, we're going to come back here. We're going to log out. And we're going to log back in. So same user this time. Of course, if I knew how to type, this would make this so much easier. Nope. Did I do this right? Kate's Lab. That's how you know the security is working, right? There we go. All right. Never save, not now. Okay. So once you run step 5 and 6, now we're on step 7. You log in. You will see that we got a bunch more buttons to push. You can click on your email address up here. You'll see that you're now an administrator and a cluster administrator. So we're going to ignore most of this stuff. We're going to start here with the Kubernetes dashboard. That's the easiest way to visualize what you're seeing. And you'll see there's not a lot to see here. You go up here, make this a little bit bigger. You'll see just this angry, unauthorized, because what's happening is you're logged into Open Unison. Open Unison is a reverse proxy that is taking your token and passing it down to the API server. So every call that the dashboard makes down to Kubernetes is done as you. This means that the dashboard, and we'll talk about this in a little bit, but the dashboard itself actually has no permissions. It can't do anything. So when people will often say, the dashboard is insecure, what they really mean isn't that the dashboard is insecure, it's that they haven't deployed it securely. They've deployed it with credentials. They've deployed it with something else. So it's really important to understand how you correctly deploy the dashboard. So as you can see, it's unauthorized. That is because we need to enable SSO. We need to tell Kubernetes, hey, trust this Open Unison instance to be able to say who the user is. So we're going to do that now. And again, if you have any questions, please drop it in the Q&A section. I get a little alert that something's been dropped in there. So next up, let's enable SSO. So let's SSH into our server. Did that. Now we need to get our API configuration flags. So this step is a little specific to Open Unison. We create the API configuration flags for you when you install the system into your cluster. And we'll talk a little bit about what these configuration flags here mean. I'm actually going to bring it to the top. Oops, make it a little easier. But this is going to be specific to each identity provider. So DEX is different than Keycloak, is different than Open Unison, is different than WSO2, et cetera. So check with your implementation on how to get this information. So the first one here is OIDC issuer URL. So this is where our JWTs come from. And what's important about this particular URL is that it has to have what's called a discovery URL available. So if I go ahead and run, see if I can do this by memory, .well-known OpenID configuration. Yep, so that worked. So this is what's called the discovery URL here. And it tells Kubernetes everything it needs to know to validate your token. It has the issuer, but obviously that's coming out of the issuer URL. It has the authorization endpoint, which is where Kubernetes, or actually really kube control is going to go to get tokens. And where you as a user will go to get tokens. It's got the token endpoint, which is part of the transference. User info, so some applications want to know more about you. They can't read the information out of the token. So this is a web services call they can use. And then it tells you where all the certificates are. Although in actuality, what's interesting about OpenID Connect is there are no certificates. Everything's basic public key, private key. So the certificates, in fact, never expire. And then you have some information about what's supported. The next one is the client ID, Kubernetes. This is just an arbitrary ID that identity providers will use to identify a relying party. Relying party in SSO terms is whoever is relying upon the identity information. In the older SAML days, this used to be called a service provider. So as a user, you're interacting with the service relies on the token. So Kubernetes can go talk to this, get all the certificates it needs, and it's off to the races. So sorry, thought that was an emergency. So that's what that first, the client ID does. Next one is the username claim. Now, the default is to use the sub parameter. The sub parameter attribute is just kind of like the user ID, UID. It's arbitrary, but this is where you would put your unique information. Again, I'm a big fan of type 4 UUIDs, something that is not based on the user's name. And then your groups claim. So this tells Kubernetes where are the groups coming from? Where are how do I identify what groups a user is in? And then finally, a certificate to identify, to protect the TLS connection between Kubernetes and your identity provider. If your identity provider is signed by a generic or a typical commercial third party, you know, like Let's Encrypt or something like that, you can skip this step. So let's go ahead and get our certificate. So let's clear this. So I'm going to go to step 3. Just check, is there anything in Q&A? No. So I'm going to go to step 3. And, oh, no, why didn't that copy? It's weird. There we go. So what this command's going to do is a little bit of voodoo for us. It's going to get the secret TLS certificate. So that's where we're storing the certificate used by the ingress controller. Piping it out to JSON. And we're using the JQ command to pull the TLS.cert entry from data. We're going to decode it, and then we're going to stick it into this file. So this is one of the beautiful things about getting used to working with kube control, is being able to easily manipulate the resulting JSON. So you should be able to check that file. That certificate's going to be there. All right. So now let's go ahead and update our API server. Now this is going to be different based on your distribution of Kubernetes. I'm using kubeadm here. There are a lot of derivatives of kubeadm that you don't realize are kubeadm. So as an example, kind, which is where you actually run Kubernetes inside of a Docker container. Great project. I love it. Actually just runs kubeadm inside of a container. So it's actually the same steps. It's just you have to then get into Docker, and this is easier for us. If you're talking about a cloud-hosted provider, so something like AKS, EKS, GKE, you can't do this. They do not give you access to the API server flags. Excuse me. I'll scratch at the back of my throat. That's where you need to use something called impersonation. We'll talk about that in a little bit. There was, interestingly enough, a KEP, which is a kind of a feature enhancement that could be used in Kubernetes requests to make this more of a object-based implementation rather than using API server flags. But it was decided that because there are different ways that this could be handled by cloud vendors already today, not to move forward with it. So let's go ahead and update our configuration. So I'm going to go ahead and get that again. I'm going to copy. Oops. Clear. So I'm going to copy this and all right. So this is where most people are going to get screwed up because YAML. So we're going to go ahead and update. Here are all the API server flags. Go ahead, go to the end. Thankfully, VI decided not to screw up the indenting. But for each of these, you're going to want to add a dash. So you should have a dash, a space, and then two dashes, just like this. Oops. So you should now have these additional 5 parameters. Those are the only ones we're going to touch for now, and save it. Now, kubeadm will restart its container for the API server. So if we do a PS into grep API, we'll see that it's actually restarting. Oops. So the API server is back up and running. If we've done this correctly, we can come back to our dashboard and do a quick refresh. It says logged in with header. Oh, that's why. Got to take off. Once you get into an error in the dashboard, you got to go back to the root. And now you can see we have access to our dashboard. Let's go over to our nodes, see how hard they're working. Now you can see all sorts of great information here. So I love the dashboard. I use it a lot. It's a really great way to quickly get information, being able to get into, so for instance, I want to go in over here, I want to debug something. Yeah, yay, I have a terminal, etc. Now that might throw some alarms to some people, like, oh my God, you have this much power. You have that much power, kube control too. You just got to handle it properly. So now that we know that the dashboard is integrated, let's see what happens with our kube control. So let's come back here. So I am now on step 5. So the first thing I'm going to do is remove my kube control context. Not her. Right? Nothing there. Kube control, get pods, nothing there. So when we talked about the authentication process, we said we went to identity provider, authenticated, and then we had to get that information, the ID token, and the issuer and the refresh token into our kube config file. There are a lot of different plugins that do that. Open Unison actually does have a plugin now where you can do kube control, OU login, host equals whatever your host name is, but you have to be on the system that it'll run on, because it opens up your browser. Other options, there are some that will let you download a kube control config file. This part is really implementation specific. There's also a kube control plugin that is more generic for OpenID Connect. It's not specific for any of the providers, where you start with a generic kube control configuration file that has everything except your ID and refresh token in it. And then it goes ahead and does all the management for you. We're going to do it a little bit differently, where I'm going to come back here. Go ahead and refresh here for a second. And you'll see this big key where it says Kubernetes tokens. So here is our token, our for the kube control. It'll work on Windows. It'll work on Linux and Mac. If we need to, we could download our certificates. And I'm actually going to take a real quick second here to show you what the JWT looks like. So jwt.io, great tool for debugging. Do not use it with production. It does not send your tokens back to anybody. But again, these are bearer tokens. It ain't worth the risk. So I'm just going to drop this in. And what's great is that this tool will kind of decode what the JWT looks like. You have your header here in red, or I guess that might be pink. Excuse me, purple is your payload, and finally blue is your signature. So this first part really just tells Kubernetes, hey, this is the key to use out of the metadata. The second part's really where the rubber hits the road. Here's the issuer. It has to line up with the issuer inside of our parameter. The audience is Kubernetes. That's going to be your client ID. Your expiration, this is the number of seconds since epoch, so like January 1, 1970, until it expires. Your when it was initiated, and you can actually see it highlights the conversion for you. Not before, because clock skew can go both ways. And then here's really where the rubber hits the road, your sub. Now I'm breaking my own rule here to make things simple, but at the end of the day, please do as I say, not as I do. And then finally, our groups. So that's all the information that Kubernetes really needs. You can include other information in there. When we talk about OPA and other potential authorization mechanisms, stuff like that might become handy. So we now have to get this information into our context. So that doesn't work. So we're just going to paste that in. And what that did is that actually got, make sure that works. Oop. Let's try logging in, logging out, logging back in. We're talking a little too much. So now you can see I'm actually able to authenticate as the user before where no user existed. Now, if we take a look here at what's actually happening, that command that you just pasted in, excuse me, that command that you just pasted in builds out your Kubernetes file from scratch. So let's go ahead and look at our kubeconfig. So it sets your certificate authority data. So that's what what kubecontrol is using to actually talk to your API server. Set your server name, set your context, who the user is. And then here's where it sets up your OpenID Connect implementation information. So your client ID, your ID token, again, authority data for talking to the identity provider, the issuer, and the refresh token. Now, here's where it becomes really important to have those short-lived tokens. They're bearer tokens, right? So I'm going to go ahead. I'm going to do kubecontrol get all namespaces. So now I'm going to log out. So this killed the session in the back end in Open Unison. Still works though, right? Because that token is good for a couple of minutes. So until that token expires, kubecontrol is not going to try and do a refresh. So we're going to go ahead and put a watch on here. And we're going to see that it's going to take a couple of minutes. Now, if you think about this in a real life scenario, the amount of time it takes someone to get a hold of this token and then know what to do with it, 1 to 2 minutes is probably going to be safe, unless the attacker is literally on your desktop, in which case you have much bigger problems than token. And there you go. Failed to refresh, couldn't get a new token anymore. So you've now gone through that whole life cycle of being able to onboard a user, SSO in, log out, and invalidate the token. So it is now 11:53, so we're a little ahead of the halfway mark. The other labs all depend on this, so I'm going to go ahead and say, let's take a short break and come back at noon. I will be watching the QA window, so if anybody has a question, please just put it there and I will be sure to answer it. And I'm going to start talking again at the top of the hour. If you hear yelling and screaming in the background, because my mic's picking it up, I promise you there are no torture session going on. It's just my kindergartner at virtual school. All right. Let's give this a try. So I'm able to get in there. I don't know if you are on like a corporate network. Maybe it's not allowing SSH out. Any command line to generate the token, create the kube config file. Yes, it won't work in this setup if you're SSH'd in, but there is a kube plugin that you could use, and I use and my customers use. Crew plugins, crew index, I guess. Is it in here? OU login, here we go. So here you can use this crew login. All right, so there is the URL. All right, private PC cannot get PuTTY to accept your key. Let me do. I don't think I have PuTTY on this particular system. Double check here real quick. Do I? No. Brew install PuTTY. Maybe. I did test PuTTY beforehand, but sometimes best laid plans of developers. All right, so let's try PuTTY. Oh. User seller. I always get this wrong. Yeah, there we go. No, PuTTY bin. Interesting. So it's not the GUI. All right, let me just double check here. I've got PuTTY running over here on a different laptop. How are we doing on time? We got one more minute and then we'll get started again. gonna double check this real quick. The putty key2.ppk. What IP are you? 157.230.86.191. Yeah, that worked with putty. I don't know. Maybe check to make sure maybe a character is not missing or something at the end. Okay, so we are a couple minutes past break. Close my other laptop here. So hopefully you've been able to get this working. If you haven't been able to get this working, typically I'd be walking around to everybody to try and help. I do apologize. It's a little hard to do that in this particular type of format. So next up, we'll dive back into it and let's talk about authorization. Actually, I apologize. First, we're going to talk a little bit more about authentication and kind of the ins and outs. So one of the great tools in Kubernetes is this concept of impersonation, where instead of going through the process that we just did of sending the token directly to the API server, you do what's called impersonation, where you have a reverse proxy authenticate the user, send its session handle, its identifier. So it's the identity of the proxy, not the identity of the user, plus a bunch of headers that will say, hey, instead of doing stuff on my behalf, the reverse proxy, do it on behalf of this user with this group identity. So this works really, really well for a lot of different use cases. One of which is if you are running a cluster in the cloud or a managed cluster where you don't have access to those API server flags, you can use impersonation to use OpenID Connect with those clusters. Now, you might say, well, the cloud providers all provide some kind of token. Why not just use that token? You might, right? I mean, that's not necessarily a bad thing. It's going to really depend on your organization, how your organization is set up. What I am finding is that customers who start off going that route start to want to move over to OpenID Connect, because that way they're not now in the middle of supporting user login process. It scales much better. So it's also good for really advanced use cases where, like a managed system where the cloud doesn't work real well, or where, I'm sorry, OpenID Connect directly does not work real well. I also like to use it where I just don't want to go through the process of having to set up all of the different API server flags. So if I'm feeling lazy and I just want to get a cluster up and running, I'll do impersonation there too. Just as a kind of a point of note, yes, the Open Unison system that you're using now does support impersonation for both the dashboard and for group control. Like I said, it works for the dashboard. It'll be working with Kiali soon, just as soon as I have time to sit down and write it. But we have opened up a feature request, and the maintainers have been gracious enough to say, yes, we will accept the PR once I go ahead and write it. Here's the trick with this. This reverse proxy here is now a privileged account. And so in cluster, use a service account. Just be really careful who has access to that service account. Out of cluster, I would probably go with a certificate here. I'm not a huge fan of certificates for users, but when done correctly with devices, they're very, very powerful. And this is one of those instances where you could properly generate a signed certificate that never leaves your reverse proxy. And that'll be a better approach than trying to take a service account off of your cluster. And we'll get a little bit more into the mechanics of certificate authentication here in a second. But really, you've got to lock that down, because in theory, that reverse proxy, you can limit this based on configuration. Most people generally don't, in my in my experience, because it's really hard to know that ahead of time. But they say, hey, that reverse proxy can now potentially impersonate anybody. That could be an issue. So you want to be careful of that. I'm just making sure the QA doesn't pop up. Oops. So let's talk about what I call second tier applications. So you're talking about things like the dashboard. I mentioned Kiali, which is a dashboard for Istio. Tecton has the beginnings of a dashboard. Lots of we love our dashboards. We have a love-hate relationship with UIs in this business. And so, these second tier applications make up more of your cluster. Even when you're talking about, like you're looking at OpenShift, right? The OpenShift management system. That's kind of a second tier, right? That's an application in and of itself. It's piggybacking off of your cluster API, sort of. But the point is that your cluster is more than the Kubernetes API. You might also be talking about things like Grafana, or your monitoring dashboards, your Prometheus, your alert manager, stuff like that. And so there is a tendency to try to do this as simply as possible, which can lead to a lot of heartburn. One such, going back to the dashboard, Tesla got dinged on this, right? They left their dashboards open. They gave their dashboard a privileged service account that you didn't have to log into, and they just, hidden URLs. Somebody figured out what the URL was, went ahead and started running some bit mining, ironically enough, not on their Kubernetes cluster, but they're able to get AWS keys and start launching some bit mining on their AWS. Some folks like to go with the port forwarding. Again, a really, really bad idea. Your browser, you can't go to a website that has, some malicious code in JavaScript that from your browser can behind the scenes access those open ports, because your browsers will stop it. But, you run a script. Oh, look at this, my dashboard hardening script goes ahead and starts deploying Bitcoin miners. So, plus you have no way to track it. It's messy. It's bad. You don't want to do it, especially not in production. In fact, I think Windows, they turned back on it, but I want to say it was 2 years ago, maybe it was sooner, where they were actually planning on shutting down access to loopback. So you couldn't run something on 127.0.0.1. So they reversed that because they realized how many problems that would cause. But the point being that once you get beyond the, ooh, I got this up and running, and you're talking about a production rollout, port forwarding is not a viable security solution. You're asking for problems. And so how do you properly do this? Well, depends on the application. Most of them will work really well with a reverse proxy. Dashboard's a great example of this. You deploy the dashboard, and this is the way it's deployed inside your cluster right now if you want to go explore it. The dashboard itself has absolutely no privileges. It's an unprivileged service account. The reverse proxy, in this case Open Unison, authenticates the user, injects a token for that user into each request that goes down to the API server, or down to the dashboard. The dashboard then takes that and sends it down to the API server. So the dashboard doesn't actually know who you are. It doesn't care. Only the API server cares. So there's nothing for an attacker to get a handle on. Now, yes, in theory, they could be sniffing traffic, but if they're at that level in there, that's a whole other set of problems that you have. This gives you a lot of great advantages over port forwarding. You have session management. You saw before how when I logged someone out, when I logged out, those sessions were no longer being generated. You have logout capabilities. You can track it. So if you're piping your logs off to some kind of security system like Splunk or Graylog or something like that, you're actually tracking who's doing what throughout your logs. You can't do that with port forwarding. You have to go back to the API server. The API server logs can track that, but it gets really messy. More applications are supporting OpenID Connect natively. For instance, Grafana now supports OpenID Connect natively. Kiali supports OpenID Connect natively, which is really great in a lot of senses. When you deploy it, especially if the application is going to interact with the API server, you gotta remember it's gotta have the same identity provider as Kate's because it's just passing that token on. Where this can fall apart is especially on cloud managed clusters where you don't have access to OpenID Connect. So for instance, with Kiali, you hand in an OpenID Connect token, you're running on EKS, that token isn't gonna work with EKS. So you need another solution for that. So let's talk about certificates and why you should not be using them. They're really easy to do wrong and very, very hard to do correctly. The power of the security of the certificate is in the idea that the private key never leaves your device. Like that's a huge part of the security of PKI. So I want to get a certificate to go to an API server. Excuse me. I'm supposed to generate a public key, private key, and then what's called a certificate signing request. Then I hand that certificate signing request off to the CA. That CA might be Kubernetes itself. It has a built-in CA depending on the implementation. Or it could be a third-party CA that Kubernetes said any certificate from the CA is going to be a valid certificate. Get signed, it comes back, I install it. At no point has the private key left my device. This is really popular with hardware devices. I'm holding up my my YubiKey here, my little buddy that goes everywhere I go. That could be your hardware device. Anybody who's worked in the federal government with PIV cards and smart cards. There are a lot of industries like smart cards, PKCS11. Very, very strong credentials, but you have to do it right. Otherwise, it's just a password file. It's just a really big, giant password file that you're passing around. So what most organizations end up doing is, that master config file that was generated when you deployed your cluster. Here, now you have access to the cluster. Can't track who has access to anything, right? Or because that process of installing and creating keys is really difficult, even for people who've been doing it for years, they say, okay, well, we're just going to generate the file and hand it to you. Well, now you've defeated a lot of the security. You might be using something like Vault to do that, to get around that. But at the end of the day, you're now starting to implement a rudimentary token management system. So why not just use the token management system that's designed to do it, OpenID Connect? So that's the first number one issue with certificates and why it's an anti-pattern for users. Groups are almost unusable. You can embed groups into a certificate. However, you have to do it in the subject of your distinguished name on the certificate of your, it's like CN equals Marc, comma, OU equals group 1, comma, OU equals group 2, right? Now here's the problem, is that the next bullet becomes there's no revocation support. So certificates will generally live anywhere from like a couple of minutes sometimes to 3 years. You know, a PIV certificate I think is actually good. I think a PIV certificate is good for like 5 years. Certificate the PKI infrastructure relies upon this concept of revocation, where there is literally just a giant list that says here are all the certificates that while their dates are still valid, we have revoked them. Kubernetes doesn't know how to look at any of those lists. It doesn't know how to pull it from an LDAP server. It doesn't know how to pull it from a file. It doesn't know how to make a request to a OSCP responder, which is kind of a service to check if certificate's valid. So once that certificate's been issued, the only way to revoke it, to make sure that it's never abused again, is to rekey the entire cluster. Cluster is a really important word in that aspect, right? There is no way, a lot of the scenarios that I've seen where people are like, well, I want to use certificates. I want to use certificates. I'm going to generate this mechanism that will quickly generate a certificate. It's going to be short-lived. Okay, you now have a token, but nobody else has reviewed your protocol. So let's go back to OpenID Connect. The other thing that's really important to understand is that for the really secure scenarios where you want to use hardware-based tokens, like my friend here on my YubiKey, right? That uses a protocol called PKCS11 to actually talk to the hardware. Kubecontrol doesn't support that, and the API server doesn't support it. I know there was somebody who was looking to implement it a while back. Maybe they have, but it just, you're not getting any of the goodness as certificate authentication when it comes to Kubernetes when you go that route. So it's good for break glass scenarios because it doesn't require a third-party identity provider the way OpenID Connect does. But for day-to-day usage, it really is an anti-pattern. If you have really strong certificates that you want to use, guess what? You can set up your OpenID Connect provider to authenticate with certificates instead of a username and password. Now you get the best of both worlds. Or you could use impersonation, where you use a reverse proxy that knows how to do all those things with validating certificates, looks up the user in a directory or database of some kind, and then injects the headers. So you can use certificates if you really, really want to. It's just don't use it directly with the API server. Use it either with OpenID Connect or with impersonation. I'll check here, anybody in the Q&A? No. All right, how are we doing on time? All right, we have talked a lot about identifying who you are. Now we're going to talk about RBAC and what you can do. So the concept here is you define a role, and a role in Kubernetes is a list of things that you can do with certain objects. I can get, list, whatever, a verb on a noun, a pod, set of pods, secrets, etc. And then you associate that with namespaced objects. Then you have cluster roles, which go for the entire cluster. You then take that permission and you bind it to somebody, hence role binding or cluster role binding. So let's say you want to build a permission that lets a service account read your logs for whatever reason or something to that effect. You would bind your permission to the service account. You can cross the stream. So you can define a role binding that has a cluster role. So a great example of this is the admin cluster role. This is a namespace role, cluster role. All of the objects are inside of namespaces to say, okay, this is your domain, use it. But you associate to it with a cluster role. So this way you're not defining a new role for every single namespace that is an admin. You're able to reuse that cluster role. So what are the things you can do with RBAC? API management, API access, and scope things at the namespace level. You can do custom RBAC verbs. I'm not a huge fan of doing it. Unless you're talking about something specific to CRs, custom resources and operators. RBAC is really good at what it does. It falls apart quickly if you try to go outside of that area. I think pod security policies is a great example where RBAC, by using RBAC, it kind of fell down a little bit. That was one of the, I think, the downfalls of pod security policies. And we'll talk about pod security policies here in a bit. Things that you cannot do with RBAC. You cannot say everything except. This one comes up a lot. I see this question all the time. Can I write a policy that gives access to everything except these two secrets? No. You have to enumerate every single thing you want to grant access to. There are really good reasons for that. One, it makes for a simpler authorization engine. Simpler authorization engine means it's easier to keep track of, easier to audit, more secure. But two, the law of unintended consequences can really bite you in the rear with RBAC. So imagine for a second that you've deployed this cluster and you've designed a role binding that lets you do everything except edit these three secrets in a namespace because those secrets are important for your infrastructure. Well, somebody says, hey, you know what? I just found this great operator from Amazon that lets me deploy Amazon resources from a custom resource definition inside of Kubernetes. So all of our users can just create some YAML and deploy an RDS database or deploy a load balancer. And now we don't have to worry about snow tickets. Awesome. So you deploy it. Well, guess what? You have now authorized everybody to be able to deploy something to AWS with whatever token you're now leveraging. So it's really, really important. If your security model relies on except, everything except this, you should probably really rethink your security model. Now, RBAC does not handle everything. There are some things that RBAC just won't do. You can write custom authorization, don't. Kind of in that same boat as custom authentication. Chances are you're not going to do it right. Security is hard. It's really easy to do it wrong. You can also do admission webhooks. Now, this is different than custom authorization. You can define a custom webhook that goes on top of RBAC. So you can say things like, if you can rely on RBAC as that first layer, and then your admission webhook is a second layer. So you're now not creating the single point of failure. No Q&A. So let's take a look at what an RBAC authorization looks like. So I color coded it here to try and map it to your URL. So here we're talking about that we wanted to make a cluster role around certificate signing requests. So this red bit here matches down with the red bit here, just the stuff, right? True of every object, the kind, metadata, where it is. Doesn't really apply directly to this. The next bit, the blue part, the rules. You can see here where things kind of sort of line up, where this is what we want to apply to. So our rule is going to apply to certificates. Our API is certificatecates.io. But notice how there's no beta here. And you could include beta, you don't have to. It's not a one-to-one map. And then finally, your resources. When you call a certificate signing request, your resource is going to look like this, right? And then it's going to be slash the name of your certificate signing request. And then there could be another request after that called approval, but you'll see that that doesn't really line up here, right? You're not going to have certificate request slash approval slash item. It's going to be slash item slash approval. So it is not a one-to-one, which is where debugging RBAC can get really messy. And then green here is the verbs. There are no verbs here. Now the verbs are what you can actually do to this object. There is a verb. The verbs don't line up perfectly to HTTP actions. A get and a list are basically the same thing, but there is not a get verb. It's a read verb, right? So it's not a one-to-one. This is the first area where I think you could run into a lot of confusion in debugging RBAC. I know I have. No Q&A. All right. So now let's look at the role binding. So this doesn't really map to the URL, right? Because the URL, we're referencing a role. And so here's our role, orchestra certs, and here's our subject. We have our service account, the name of the account, and the namespace, Open Unison. Now, here's something to think about when you're designing your RBAC policies. Let's go back to authentication. If you're going to reference every user inside of your RBAC policies, one, the subject list can get big kind of quick, right? But the other thing to point out is that when you're using OpenID Connect, your subject is not Open Unison -operator or like Kate's-lab. It's your issuer pound Kate's-lab. I think I have an example of that in a couple of slides. So if you move your identity provider, you've got to change your entire all your RBAC bindings. Additionally, you can't search and say who has access based on what RBAC bindings does this user have. You have to enumerate every single binding and figure out which one they're a member of. That can get messy kind of quick. When you want to deprovision someone, we always talk about onboarding. What about offboarding, right? My job function changes, I leave, I get walked out, right? Not a happy thought, it happens. How quickly can you deauthorize access? Well, if you gotta go through every single RBAC binding to figure out where the user is, that can be painful. Whereas if you're using groups and embedding those groups inside of your tokens, you now have much cleaner RBAC policies. And we started to talk about the subject type. So service account, it's scoped to a specific namespace. User, like I said, for OIDC, you have to prepend with the issuer. Group is really where you want to be, unless you're doing service accounts, because you can't add service accounts to groups. There are some specific groups for service accounts, but those get generated automatically. You can't have arbitrary groups and service account memberships because there are no groups in Kubernetes. There's no group object. So really the best practice is down here, using groups inside of your binding. So lab 2, let's put some of this to the test. So what we're going to do now is a couple of things. First thing we're going to do is enable the, we're going to go ahead and enable the audit log. And then once we've enabled the audit log, we're going to go ahead and debug the process of designing an RBAC policy. So just like before, I'm going to go ahead and do this as well. And I'm going to go ahead and close this down. And so on the training, we are now on lab 2, step 1. So the first thing I'm going to do is I'm going to log in with this make NS user. Now, this is an unprivileged user. I don't have access to anything. You can see I don't have anything over here. So let's go ahead and, of course, I forgot to, authorize user. Okay, so what we are then going to do is going to go request access, going to go to namespace here, and we'll talk about this in a little bit, and just pick one and add to your cart. Submit. Go ahead and log out. Log in as our Kate's Lab user. Got this little open approval up here. Click review. Approve the request, confirm approval. All right. So sorry about that. Hope you were able to follow that. So now I'm going to log in with MakeNS. Now you'll see I have Kubernetes token access. So I'm going to go ahead and log in with kube control. So list of namespaces. So once I have that access, now another way that you can go about doing that a little quicker. Where did, okay, there it is. So log in as Kate's Lab. Not now. Go over ahead and click on Operators Console. Search, pick that, go to Kubernetes namespace viewers, run, test, temp pre-approval, approved, test. And that will also go ahead and enable the user, and then you can log out. Oops. You can log out and then log in as MakeNS. So grab tokens and same thing, kube control, get nodes, or I'm sorry, pods, namespaces. There we go. All right. Okay, so now we have a user that is not able to do a whole heck of a lot. So let's show off trying to create creating a namespace. That did not work real well. You can see a bunch of information about what didn't work. Now you'll notice here, this is the user. Identity provider, hash, MakeNS. That can get really hard to manage when you do it at the user level. And the messages have gotten a little better, but this is still kind of difficult because when you look at this error message, it doesn't line up directly to the information inside of the role binding. So what we're now going to do is go ahead and enable the audit log. So I'm on step 4. Now, most modern, when I say modern, right, because we've been doing this for what, 5 years? Most modern Kubernetes implementations, the API server runs as a container, what's called static container. So like when we edited our API server configuration, there was a container that had to restart. So in order to enable the audit log in kubeadm, you need to make sure that there are places for it to get written to on your local system and then mount that into your API server. So that's what we're going to do here in step 4. So we're going to create where the logs go. We're going to create a place to store the configuration. Now, we went ahead and put together a policy for you just to make life easy. And then finally, we're going to update our API server configuration. Now, the first thing we're going to need to do is add our server flag. So this is what's going to tell the API server oops, jumped the shark there. So this is going to tell the API server, hey, generate an audit log, and this is where. Next thing we need to do is go down to our volumes, or volume mounts rather, excuse me. And we need to add this. And of course, because YAML, we need to make sure that we get our spacing correct. And then finally, we come down to the volume section here, and we add some host paths. So that way we can go ahead and pull up or talk to our make sure everything lines up. All right, so if I've done everything correctly, and we can see that the API server has restarted and we are up and running. Now let's go ahead and take a look at our logs. And you can see we're generating a bunch of logs. Now these logs are in JSON format. I am not Keanu Reeves. I cannot read this stuff as it scrolls by. But we're going to try doing this again. And this time I'm on step 5. We are going to see what happens. So I'm going to go ahead and try creating my namespace. Still fails. But this time, let's see what happens in our logs. So we actually have, I'm going to do this, make it a little easier to read. We have some status objects come through, events that actually tell us everything we need to be able to authorize this access. But here's the thing. That's kind of tedious and difficult, and I'm lazy. So we're going to use a great tool by a man named Jordan Liggett. If you have ever asked a question on the Slack channel, he probably will be there to help answer it. Great guy. Called Audit to RBAC. And so what Audit to RBAC will do is actually take this and generate a policy binding for you. So let's go ahead and do that. So I'm going to do this, clear. And then because our user is in there, we want to make sure to update our IP address. Another reason why doing things directly by user is a terrible idea. So now we have this new RBAC. Let's take a look at it real quick. Now there's a bunch of stuff here. Let's see if I can make it work a little bit more. No, all right. Oops, don't want to make it that big. Creates a cluster role for namespaces, creates our role binding. Now, of course, this is a lot of really hard stuff to read because you can't put URL, full URLs inside of the YAML as annotations. But this has now created a full policy binding for you. So let's come back here. Where'd I go? I'm running short on time, so I'm going to go ahead and move through this kind of quick. So I'm going to switch contexts here real quick. And I'm going to now apply our RBAC. And now I'm going to reset my kube config. So now I'm back to, I'm back to my original user, and I'm going to try to and bada bing, we've now been able to actually debug our RBAC implementation. I swear by the audit to RBAC tool. I will often use it as a starting point for trying to design, because there are just sometimes I will stare at RBAC bindings and feel like, oh my God, but this should just work, and it doesn't. So what do we got with Q&A? Then apply permissions to the aid. So you guys integrate with OpenShift, user management, RBAC, it's a grind, very cumbersome in OpenShift. Do not understand why you have to log into the cluster first, then apply permissions to the AD user. I think where some of the confusion's coming from, and I haven't explained it real well, is the permissions don't actually live in AD in this particular setup. They're living in a database. And so we don't actually give you access to anything until you've been authorized to access something. So that song and dance, which I think is what you're referring to in the very beginning, where I actually had to log in. Oops, come back here. Where I actually had to log in and go and request access. That's because none of these permissions exist inside of Active Directory. We do have our login portal, which will just take permissions from Active Directory and put them directly into, and map them directly into RBAC bindings. We didn't go with this one here because we wanted to show the power of automation, which we're going to be talking about next with a best practice when it comes to authorization. And so we're actually going to talk about that really, really quick before we move on to pod security policies, because we are running short on time. So we just went through all this. This is the actual building out. I'm not going to repeat that. Automate, automate, automate. So when I say automate, 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 this is what I mean. Instead of creating a namespace, then creating RBAC bindings. Oh, by OpenShift with itself. Let's talk afterwards so I can make sure to answer your question correctly. One of the keys with Kubernetes is automation. You want to create a new namespace, don't create the namespace with the groups and the roles all manually. Have something that does it for you. Example, go to create a new namespace. Who am I logged in as? Make NS. I'm just going to log out of this to make my life easier. So I'm going to log in as my Kate's Lab user. All right, so you want to create a new namespace, some new namespace, test. Submit the request. You then need to, somebody then needs to approve it. Obviously, this wouldn't be you, but. And so you're going to give a reason. test. Now you confirm that request gets created. And now what's happening is that we're creating the namespace, we're creating the role bindings, we're creating the groups inside the database so that moving forward, if somebody wants to request access to that namespace, they don't have to go through me as the IT person, they go to the owner of the namespace. So you as the owner get out of the loop. That type of automation, whether you do it through us or you do it through some other mechanism, becomes really important because now all of your namespaces are created in a consistent way. So like here's some new namespace, right? So that got created for you. The role bindings are there for you to be able to start onboarding users into groups. We create the groups in the database. And so that kind of repetition makes it so much easier to manage. And that's what I mean by automate, automate, automate. Use groups for user access. Again, you saw that big gnarly user string. If you use groups, you're going to make your life so much easier. The RBAC bindings become so much simpler because now you can automate the creation of those bindings without having to update them all the time. You could use things like GitOps, but again, it just automate everything. And then externalize service accounts where you can. So where I say this, saying here is not necessarily the word service account, but service accounts. So I've got a lot of customers that use privileged access management systems, and they didn't want to use service accounts for their CI/CD. They already had invested hundreds of thousands of dollars in this privileged access management system. So we said, okay, let's use that as your service accounts. And they were much happier with it, saved them a lot of time. So just look for things like that, especially when you're in the enterprise world. And then reuse cluster roles when possible. And we talked about automating namespaces. So pod security policies. I'm going to kind of run through this one really quick. I want to be mindful of time. Your RBAC protects your API server. Pod security policies protect the nodes. So, making sure that a node cannot, or a pod cannot hurt a node. All of us had our account information from Equifax. Was it Equifax? One of them stolen, right? That was because of a Struts API vulnerability. Struts API vulnerability gets chained into a local code exploit. All of a sudden, your Java web app is now a vector to be able to infect your node. There's this concept that pod security policies are hard. They're really not as hard as they may seem. What makes them really hard is the fact that most people, we spent 30+ years saying don't use root, right? Before we started with containers. And then we started with containers, like, no, root for everybody. So what ends up happening is you start getting these containers that are from Docker Hub that run as root and won't run in a pod security policy setup. So if you're familiar with OpenShift at all, you'll know that that Red Hat will produce a lot of the containers that the official Docker containers have, because those official Docker containers run as root. Now here's the problem. For a lot of reasons, pod security policies have been deprecated. The original plan, was not to remove them until a replacement was decided upon. Starting in 1.19, I think it was either 1.19 or 1.18, there was a blanket policy put in place for APIs that says, look, an API does not move out of its current version towards GA. So if it doesn't go from beta to alpha to beta, beta to, with GA within 3 cycles, it needs to be removed. That's, because nobody really wants Ingress to stay in beta for 5 years again. And since there will be no successor to pod security policy, or there will be no updates to pod security policies, they will be removed in 1.22. So I guess that does put pressure on the rest of the industry to come up with a replacement. I have not found a replacement that I really like yet. I still go with pod security policies. So I'm looking forward to what the industry comes up with for replacing PSPs. Definition of a pod security policy, really not that crazy. What can you run as? What can you do? What kind of volumes do you have access to? Often what you'll end up seeing is a lot of vendors are creating pod security policies. So for instance, the ingress controller from Nginx ships with a pod security policy that you can apply. And then you apply it using a cluster role. This to me is where I think a big part of what's hard about pod security policies is, because there's absolutely nothing intuitive about this design. I get why they did it this way, because you need to somehow tie your pod security policy to a pod and figure out how, which ones are potentially applicable and ways to authorize it. But I think it was kind of a square peg round hole with RBAC. So here's where things get really hairy with pod security policies, is your pod security policy is authorized based on a union of the identity that deployed it and the identity it runs as its service account. But the identity that deploys the pod is not the person who created the deployment. So we don't deploy pods anymore for the most part, right? We deploy higher level constructs, deployments, stateful sets, jobs, which then are intercepted by controllers or watched by controllers, which then will set up your pod for you and control your pod. Well, the identity of the creator is not the person who created the deployment, it's the controller who created the pod. And that's where things can really get hairy with your authorization process. Okay, lab 3, pod security policies. Do a quick time check here, see if I can pull this off. I think I can pull it off. Let's see here, this is actually a really quick lab. You know what? I'm actually going to leave this one for another time because we still have some really good content to cover. I suspect I probably lost a lot of people, unfortunately, with the last lab. So let's come back here. Anybody who wants to be able to do this afterwards, just give me a shout. We'll figure out a way to handle it. So best practices with pod security policies: pressure your vendors for same defaults. That's, I'm going to give so many props here to Red Hat. They don't actually use pod security policies. They have their own thing in OpenShift called SCCs. Same concept though, slightly different implementation, but they have sane defaults. Unless you need to interact with the host, chances are your pod does not need privileged access. And so if your vendor has some sane defaults, that'll make your life a lot easier. Don't run your containers as root. When in doubt, you want to test something out, see if it's going to work in most environments. I'll give another shout out to Red Hat on this one. Go ahead and grab their OpenShift developer kit, launch it on a on a laptop. You're good to go. If it'll run on OpenShift, it'll run on anything. Most constrained security environment out of the box that I've seen. Do not assign privileges to a default service account in the namespace. You need your pod to run as a specific service account with specific privileges. Create the service account, assign the privileges to that. It'll be much easier to audit. And then just like before with RBAC, automate, automate, automate. Admission webhooks, this lets you extend things. Total 5-hour course on its own. So many things you can do with Open Policy Agent and Gatekeeper. But like I said, it passes in the identity of the requester, which could be a controller. So you gotta be careful about what you're writing authorization rules based off of. And this is the exact same scenario. Real quick war story. I've got a customer using OKD and Kerberos. We ended up having to write custom admission webhooks to be able to validate, things like a persistent volume was being claimed by the correct user, not just any user that was waiting for it. Because you could write a persistent volume claim that just sits there and waits for a persistent volume to become available. And so this became a big issue with us, where the identity of the user that was passed in was the controller, not the user. OpenShift, they have their own identity provider built in. So even though I'm logged into the OpenShift identity provider, the group information the information about the user, the auxiliary information that I might use to perform authorizations from, doesn't actually make it in, because I'm getting the identity from OpenShift's built-in identity provider. So it can get a little hairy there too. All worked, but a lot of intricate details you gotta be mindful of. So thank you very much. We've got a couple of minutes left. I'll see if I can answer any questions real quick. Otherwise, I'll make myself available after the fact. We'll figure out how that works. I think there's a place we can go in the conference system. Find me on the web and Twitter. All our stuff's on GitHub, including, we'll shoot out the link, the lab for this. So if you want to set up this lab at home, you have a Linux server, you have Active Directory, you can actually get this lab set up at home. It's just an Ansible playbook, you're up and running. And then some really shameless self-promotion. I have co-authored a book on Kubernetes and Docker for the enterprise. So in addition to the deep dives of what we did today, you're talking about backups, log management, real deep dive on how to write OPA policies. As you can tell, we weren't able to get through 2 hours here. The topics that we had. So these are a lot of really great topics, and it all culminates with provisioning a platform. So integrating Tecton, Open Unison, Argo CD, and GitLab to kind of build a automated platform. You see how all the objects relate to each other and the webhooks and whatnot. So that comes out on November 6th, available for pre-order now. Use that code right there, 25 Kubernetes, for a 25% discount, I think, until November 15th. So with that, I will see if there's anything in the Q&A. What do we got here? Yes, I am going to do that right this second. GitHub.com, Tremolo, security, IDM. Here we go. So here is the, I'm going to put this in the chat so everybody gets it. All right, and then I will be, that has a link to the slides. I've actually updated the slides a bit, so I'm going to go ahead and post those to the slide share. Any other questions? I know we're coming right out down to the wire. I like to leave a little more time for questions and answers. I'm going to go ahead and do just a little more shameless self-promotion, because why not, right? And then here is the discount code. All right. I think that's it.